Hello students, welcome to SOURAV's classes. Today we'll be solving the part 1 of TIFR maths question paper of year 2017. We have solved question number 1 to 17 in the earlier videos. Today we'll be solving question number 18 and 19 from the same paper. Let's begin with question number 18. In question number 18, it has been said that let f be a function which goes from 0 to infinity where the set is closed, where the interval is closed at 0 and it goes from 0 to infinity to the set real number system R, and the function f is a continuous function with limit x tends to infinity fx is equal to 0 as x tends to infinity. So we have to find out whether f has a maximum value in that interval 0 to infinity which is closed at 0. We have to find whether this statement is true or false. Now let's begin. Now it has been said that the function f goes from 0 to infinity to R. Also, limit x tends to infinity f of x is equal to 0. I can think of a particular function where this happens. We can take fx is equal to 1 by x, and if we take fx is equal to 1 by x, then we can show that fx equal to 1 by x doesn't have a maximum value. In the interval 0 to infinity. So the statement that we have to check over here is false. Now let's move on to the next question. Here comes the next question, question number 19. In question number 19, it has been said that given a continuous function f which goes from q to q, this is the set of rational numbers. Q denotes the rational numbers. The function f goes from q to q, and there exists another continuous function g which goes from r to r, and there is a restriction of f of g to q is f, and the restriction is that the restriction of g to q is f. So in other terms we can show that we can tell that if f goes from q to q and g goes from r to r, and the restriction of g to q is not only just q to q, it's q to q, and such that the restriction of g to q is f. Let us assume a particular since the function f is defined over the rational numbers, we'll take a value m by n, since m by n is typically the structure of a rational number, and we'll take that the function m by n is equal to 1 by n. Or we can also assume one more we can take one more assumption, that we have to check the over g, we have to check some rationality or irrationality thing. So let x be an irrational number. Now let us take a particular value of x. Let x be we can consider x to take the values 0.1, 0.101, 0.10101, and so on. It will go on. In that case, g of x will come down to 10,000 10,000, and so on. Actually it will tend to these values. And also by continuity, g of x is equal to 0. So if we take any irrational number, in that case also g of x is equal to 0 for all x which is irrational. So therefore it is not continuous and the statement is false. So today we have solved question numbers 18 and 19. We'll be solving the next questions in the upcoming videos. Thank you.